So guys, so we'll move to the next question now, which is question number 2028. So number 28, right? We're given an equation A plus B to give C delta H is equal to positive. Then this is the actual question. For the reaction above, which of the following is correct? Option A, BBE, which stands for bond breaking energy, equals BFE, bond formation energy. Option B, BBE less than BFE. Option C, BBE greater than BFE. Option D, none of the above. Now, hope you're still with your writing material. So you put down this question on your notes. Try to answer the question and watch me explain and see if you are correct. Now, in this question, we're given an equation and they said that which of these options is correct. Now, this reaction is a what? An endothermic reaction. For the overall reaction, delta H for the reaction is positive. Now, one thing you should know is that for a reaction, two things majorly occur. For a reaction to occur, two things mainly occur. Bonds will break and bonds will be formed. Bonds will break and bonds will be formed. That means for a reaction to occur, there will be bond forming process and there will be bond breaking process. Now, bond breaking process usually occur at the reactant stage, while bond forming process usually occur at the product stage. That means usually products are formed by bond formation. Reactants will undergo bond breaking. That means reactants will break, undergo transformation, then these substances formed will what? We join together, we bind together to form the product. Like I said before. Now, one thing you should know, bond breaking usually requires heat absorbed. Bond forming usually release heat. Now, I want you to do something for me. Whenever you are joining, whenever you are bonding to substance, heat is usually released. Let's try it. Try to clap your hand together. You will see that you will feel wind coming out. So that shows that whenever two substances join together, heat is usually what? Released. Now, but to open this substance, heat is absorbed. To break it, heat is absorbed. To join it, heat is released. Now, for a reaction to occur, usually the reactant will undergo bond breaking process. The product will undergo bond forming process, majorly in most reaction. Now, for the overall reaction, heat of the reaction is usually equal to the sum of bond breaking process energy plus bond formation energy. Now, these two together will give us the heat of reaction. The sign of this heat is dependent on which of these is higher. Now recall that this usually absorbs heat. This usually what release heat. So let's assume that this bond breaking energy is higher than this. Put a value 6. Put a value that is lower than this, because I'm trying to see this greater than this. Put a value 3. However, there must be sign to indicate absorption of heat and release of heat. Absorption of heat usually take plus. Release of heat usually take minus. So I'm going to put plus here and minus here. So if I do this mathematics, I'm going to have plus 6 minus 3. This will give me plus 3. So the heat of the reaction, delta H of the reaction, will be positive if bond breaking energy is greater than bond formation energy. Now, let's see what will happen if bond formation energy is greater. Now, let's see if this is greater. 6, 3. Add the sign. This is usually plus because heat is absorbed. This is minus because heat is what? Released. I'm going to have plus 3 minus 6. This will give us what? Minus 3. So the delta H of the overall process of the reaction will be negative if bond formation energy is greater than bond breaking energy. Are you seeing it now? Now, I want you to take note of this. For example, we are given something like this: delta H minus 30 and minus 50 joules of heat. One thing you should know, the sign does not affect the magnitude. I don't know if you are getting it. Mathematically, we are supposed to say that minus 50 is less than minus 30. No, the negative sign here does not affect the magnitude. The negative sign just means that heat is released. Remove this thing now. Who is greater? 50 joules is greater than 30 joules, to show that these heats are not absorbed, but they are released. That's why I'm putting this minus sign. Take note of that. So, for that, we cannot answer this question. Delta H will be positive if bond breaking energy is greater than bond forming energy. Delta H of the reaction will be negative if bond breaking energy is less than bond forming energy. Please take note of this. I've been able to prove it. Now that we know this, can we then answer that question? Yes. For this reaction to be endothermic, the bond breaking energy should be greater than the bond forming energy. So option A is wrong. Option B is wrong. Hopefully, we should know that option D is wrong. So the answer should be option. The answer is option C. So can put this down. Why? Pause it, right? So I can forge ahead. So I can clean this part of the board. We move to question number 29. Question number 29. Which of the following reactions is exothermic. Option A, we're giving CaCO3 to give CaO plus CO2. Calcium triazocarbonate to give calcium oxide and liberate carbon dioxide. Option B, Fe iron plus sulfur to give iron 2 sulfide. Option C, NaOH plus HCl to give NaCl plus H2O. Option D, CH4 plus 2O2, 2 oxygen to give CO2 plus 2 H2O. So this is the question, the next question, question number 29. Now we're asked which of this is ESO. Is it ESO? Please, let's correct it. Endo. Correct it, please. Which of the following reaction is endothermic, not exothermic? So correct it. So let's observe. Now, check. If you understand the concept of what I did here, we can actually get this answer with ease. Now, for the first question, this compound, this reaction rather, is a decomposition reaction. In a decomposition reaction, we have one reactant and several products. What it means is that one reactant break into several products. In the process of breaking, remember, bond breaking requires energy. Bond breaking is usually what? Endothermic. For the second reaction, this second reaction or this second what option is a combination reaction. A combination reaction, we have several reactants but one product. But what is happening here? X is joining with what? Fe. Once you join, heat is what? Release. Just clap your hand like this. Heat is what? Release. Are you seeing it now? Now, the third or option C is neutralization reaction. And all neutralization reactions are exothermic. All neutralization reactions are exothermic. Follow me in this series, you see why. Then option D is combustion reaction. Methane is being burnt in oxygen to give CO2 and what? Water. You also recall all combustion reactions are exothermic. So the only option that is endothermic here is option A. So delta H for this reaction here is positive. Delta H for this reaction here is negative. Delta H for this reaction here is also negative. Delta H for this reaction here is negative. So the answer is not D, is not C, is not B, but the answer is option A. Good. So can I clean the board? Because I want to clean everything now. So we'll move to the next question. So we'll move to the next question, which is question number 30. Question number 30. This is question number 30. Which law of thermodynamics, law of thermochemistry states that the heat of a reaction is the same whether the reaction occurs in one step or in several steps. Option A, Laplace law. Option B, Hess law. Option C, Lenz's law. Option D, all of the above. So I hope you have this on your note. Pause it and write, then choose any option, then play to see the correction, play back to see the correction and see if you are correct. Okay. Now, the law of thermochemistry is actually different from the law of thermodynamics. Then the law of thermodynamics, I think we have like, at least we have first law, second law, third law, zeroth law, several laws of thermodynamics. But you see, there are two laws of thermochemistry. Two laws of thermochemistry. One is Hess law of heat of summation. It is also known as Hess law of constant heat of summation. Then number two, we have the Laplace and Lavoisier law. So these are the two laws of thermochemistry. It's actually different from the laws of thermodynamics. But however, we are going to look at this first one because that's what is on the board here. According to the law of constant heat. Let me write it here. Of summation, also known as what? Hess law, which states that the heat of a reaction is constant, is same, whether it follows one step or several steps. I'm going to explain this. For example, if A reacts to give us B, and this is the heat of the reaction. If it follows one step from here to here, and this is the heat of the reaction. If it follows several steps, let's say A transform to C, C transform to Q, then Q now transform to B. These are several steps before we go to B. I'm going to call from here to here the heat associated, I call it delta H1. From here to here, the heat associated, I call it delta H2. From here to here, the heat associated is called it delta H3. A simple question. What is the heat of the reaction? The heat of the reaction is not equal to delta H3. It is the sum of everything. It is the heat that converts A to C, plus the heat that converts C to Q, plus the heat that then converts what? Q to B. So the heat of the reaction is constant, whether it follows a single step or it follows several steps. I'm going to have delta H1 plus delta H2 plus delta H3. Are you seeing it now? So whether it follows one step or it follows several steps, the heat of a reaction is constant. Clear? So the answer to that question is not Laplace law, it's not Lenz's law, it's not all of the above. The answer is what? Hess law. And Hess law is also known as the law of constant heat of formation. The law of constant heat of formation. So take note of this. I hope you have it on your notes now because we want to clean. But however, I know you're asking, why didn't I explain Laplace law or Lavoisier law? Because I know that in subsequent questions, I'm going to explain Laplace law and Lavoisier law. So I'll want to clean now. All right. So now we move to the next question. Question number 31. Question number 31. So with that little question I explained, I still have if you don't understand, I would like to buttress on it so it becomes very easy. For example, look at this. If H2O solid is being converted to H2O liquid, what just happened here is what? Melting. And melting is also called what? Fusion. This heat here is the latent heat of what? Of fusion. Right? Yes. However, what of if I did not go straight? I first of all heat this guy to become gas, H2O what? Gas. Then condense it, sublime. I'll call this heat 1. Then condense heat, right? To give me this, let's say delta H2. Now, this from here to here, the sum of from here to here to here will be equal to this. That's what we are trying to say. So delta HF will be equal to delta H1 plus delta H2. So that's just one of the simple explanation of Hess law, which is what? The law of constant heat of formation. So that's it. It's not that complicated. So move to number 31, which is which law of thermochemistry states that the heat absorbed is equal to the heat liberated when the reaction is reversed and vice versa. Option A, Laplace Lavoisier law. Option B, Hess law. Option C, Les law. Option D, none of the above. Now, I just told you before that we have two major laws of thermochemistry. We have Hess law and Laplace law. Now, if we understand the concept of Hess law, we should know that this is not talking about Hess law. Automatically, we should just by default know the answer. The answer should be Laplace Lavoisier law. What Laplace Lavoisier law is telling us is that if a reaction is reversible, let's say A plus B to give us C plus D. Now, if the heat of the forward reaction is, let's say, minus 30 kilojoules, that means if heat is released and the quantity of heat released is minus 30. If we are going back, the heat absorbed will have the same magnitude as the heat release, but just change sign. So going back, if heat is released in going forward, heat will be absorbed in going backward. The amount of heat absorbed will be equal to the amount of heat what released. So the delta H for the backward reaction will be plus 30 kilojoules. They will not change in magnitude, however, they will change in sign. So if the forward reaction release heat, the backward reaction will absorb the same amount of heat, and vice versa. If the forward reaction absorb heat, the backward reaction release the same amount of what? Of heat. So that is the concept of what? Laplace law. I hope you understand this, because we'll need this to solve subsequent questions. So our answer is not Hens law. Our answer is not Lenz law. The answer is Laplace and Lavoisier